Hi there, my name is Thiamin, also known as vitamin B1. If you don't mind, I like to introduce you to myself and explain who I am, my role in the human body, where to find me, what happens when I'm incorporated too much or too little in a diet, and a few extra fun facts. First things first, let me give you a little background information about myself. I was first discovered in 1910 by the Japanese scientist Umataro Suzuki. But I didn't get my name until 1935 from American scientist Robert R. Williams, who also discovered my chemical composition and synthesis in the human body. I am made from the elements carbon, hydrogen, nitrogen, oxygen, and sulfur, and my chemical formula is C12H17N4OS. I don't dissolve in alcohol, and I break apart when it gets too hot. So, now that you know me a little better, let me tell you about my role in the human body. My main job in the human body is helping out with the process of cellular respiration. You can find me at the beginning and the middle of the action of the citric acid cycle, along with my three buddies, CoA, pantothenic acid, NAD or niacin, and FAD or riboflavin, who also happen to be B vitamins. To start the process of the citric acid cycle, it's crucial that the molecule pyruvate be converted into acetyl-CoA, the first molecule in the citric acid cycle. To do this, I use the process of decarboxylation, of removing carbon dioxide from certain compounds. In the middle of the citric acid cycle, I use decarboxylation again to remove carbon dioxide from alpha-ketoglutarate, converting it into succinyl-CoA, and thus continuing the process. In the middle of the in the nucleus of the cell, I also play a major role in creating the blueprint of the human body, DNA and RNA. Although I don't do this by myself either, I work as a coenzyme, or co-worker as you might call it, to the enzyme transketolase. Together we convert a 6-carbon glucose into a 5-carbon sugar, which is used to build the structure of your DNA. I don't want to toot my own horn, but I'm pretty important. Without me, the human body takes a heavy toll on energy. Because without decarboxylation, it's hard to keep the process of cellular respiration moving, and the body continually synthesizes new cells with my help in creating DNA. Staying on this topic, let's talk a little bit about what happens when a person gets too little or too much of me in their diet. Do you remember my friend Umataro Suzuki? During the late 1800s to early 1900s, the government of Japan in this era commissioned researchers to find a cure to a disease that was ravaging the nation and known as beriberi, which translate to I can't, a perfect description of the symptoms of this disease, which includes fatigue, irritability, poor memory, loss of sensation, and muscle weakness. When left untreated, beriberi may cause congestive heart failure, eventually leading to a person's death. Through his research, Suzuki discovered that this disease mainly affected members of the Japanese Navy and the poor, whose diet consisted mainly of polished white rice that underwent the process of removing the outer shell or bran of rice. From the bran, Suzuki, along with his student, successfully isolated what they called aperic acid. Giving sufferers of beriberi foods containing aperic acid cured the disease, and Suzuki in the process became the founding father of vitamin research in our modern age. Another disease known to be caused by thiamine deficiency includes Wernicke-Korsakoff syndrome, a syndrome that is associated with the life-threatening Wernicke's encephalopathy that causes peripheral neuropathy, which leads to death, or Korsakoff psychosis. Common aspects of Korsakoff psychosis include severe short-term memory loss, disorientation, and confusion between real and imagined memories. People who are at risk of developing thiamine inadequacy include people with alcohol dependency, older adults, people living with HIV and AIDS, people with diabetes, and people who have undergone bariatric surgery. On the other hand, there have not been many reports of people suffering from thiamine toxicity. Because of this, no standard upper limit of thiamine intake has been established. However, that does not mean that there are no adverse effects of taking excessive amounts of thiamine, so remember to be careful and keep your thiamine intakes at the advised amounts. So, now that you know the importance of thiamine in the human body, let's discover some good sources of where I come from and how much you should incorporate me into your diet. Good sources of thiamine include whole grains, meat and fish, and fortified foods. As you can see from this recommended dietary allowances chart, thiamine is a small part of the diet, but as you've learned, it's also very important. Oh, one last thing before I go. Did you know that thiamine deficiency may be a cause in developing Alzheimer's disease? According to the animal studies performed by Gibson and other researchers, animals found with thiamine deficiency were more likely to show signs of oxidative stress in neurons, death of neurons, loss of memory, plaque formation, and changes in glucose metabolism, all of which are strongly associated with Alzheimer's. So remember to get your daily dose of thiamine. Well, I hope you've enjoyed learning about me and the important functions I serve in the human body. Remember thiamine. That's me. Is like the scripture Alma 37:6. By small and simple things are great things brought to pass.